This is a small tutorial on how to run a power flow simulation using ARTERE. So when you download the material from the VLE, from Minerva, you're going to find the following files. First one, we have ARTERE_i.exe, so this is the actual simulator. If you double click on that, you will get this window popping up, and it's asking you to input some data files. Now the data files are the data file that we're going to use is called 6bus.txt, and this is a text file that has a description of our 6-bus microgrid. So you're going to see here we have a declaration of the buses. These are the buses of the system, and declaration of the lines, of the transformers, the generators, and which one is the slack bus in the system. So if you open here, you have these two PDF files. The first one is a user guide. So in there you're going to see a step-by-step information on how to load files and how to run some power flows. You're going to see a lot of information. We're not going to use all the features of ARTERE, but feel free to go through and play with the software and see what are the capabilities. The second one here is ARTERE data. So this one describes how we input data into ARTERE. This is a description of the TXT file that contains all the devices. You'll see here how do we input a bus, how do we input a line, how do we input the transformers, and then you can go, for example, to the bus record. It tells you that first we have to put the bus, which is the type of the record, then it's the name of the bus, then is the nominal voltage in kilowatt, then is the load attached to the bus in megawatt, the active load, and the reactive load in megavar, etc. We have the same thing for the lines. You can see this here. We have the same for the transformers, where here you also have a small description on the per unit system used to declare the transformers. And then there are several other models, several other devices that you can put into ARTERE. So if we go into ARTERE, so here it is, we'll just maximize it. I will write here the name of the data file that I have given you. So it's 6bus.txt, and then I press enter. We don't have another data file, so I press enter again. So here you can see the Newton iterations. This is a power flow solver that uses the Newton-Raphson method. Here you can find some information on the parameters of the Newton-Raphson method. And here you can find the iterations. It took 3 iterations for the system to converge. Now if I want to see the results, then I can go to outputs, show listing, and then I can ask for the bus voltages, for example, and then display. And then here in a text file, I get for each one of the buses what is the bus magnitude and voltage magnitude and phase. And this is in SI, in kilowatt. So I can also ask for a global power balance, for example, and here we're going to see what are our loads, the generation. You'll see here there is how much is produced by the slack bus and by others. So since we have only 2 buses, then this is the slack bus, and then this is the second generator. And then we can see the network losses, so how much active and reactive power we're losing on the network. Now, in order to produce the one-line diagram of the system, we have to go to Output, show on one line diagram, and then you have to put here the name of the SVG file. Here it is, I have given to you with the data files. So it's 6bus SVG. So I write here 6bus.svg. I press enter. Now you need to give a different file name on where to save the one line diagram. I'm gonna put out.svg. Okay. Now this has been generated. If I go back, you'll see here you have out.svg. The SVG file is a vectorial file that you can open with any browser. So I'm gonna just drop it into Firefox, and here you can see the one-line diagram after the PowerFlow solution has been performed. You can see here all the magnitude of the voltages. So these two are generator buses, so they're at 1 per unit. This is the slack bus, so we have the phase being at 0. Then we have all the power flow over the lines. You can compute the losses by summing the power coming from one side and the power coming from the other side of the line. We have the power over the transformers, and we have the power of the loads, etc. Before coming to the course, I strongly suggest that you check the project description. So you will find this on the VLE. You check the ARTERE user guide and ARTERE data. That's all.